So the last video we discussed the process of inflammation, and you may be saying, Professor Riley, you didn't say anything about fever and inflammation, because those two processes do tend to kind of go together. The inflammatory response can trigger fever, all right? So in terms of that inflammatory response, remember, we have three main stages. There are a couple steps within the main stages, but you're going to have some vascular changes that are going to happen. Remember, when you have that injury, damage to the blood vessel, and the release of histamines and cytokines from the local cells will recruit white blood cells. It also sends a signal to dilate the blood vessels or result in vasodilation. So we've got vascular changes that happen. We've got the cellular changes that happen, the incoming of those phagocytes like the neutrophils and the macrophages to kind of clean things up. And then eventually you've got repair with the inflammatory response, all right? Where fever comes into play on this process is going to be at the cellular level, because what's going to happen, you're going to have with those white blood cells, like the neutrophils and the macrophages breaking things down. The macrophages in particular breaking down those bacteria that may come in with it. And in terms of bacteria, remember we talked about gram-negative bacteria having that lipopolysaccharide layer, or LPS, all right? LPS is a potent pyrogen, all right? And in terms of that, you've got the prefix here, pyro, all right, which goes along with fire, all right? We're not causing fires within the body, but those molecules associated with LPS are what contribute to the fever that can go along with an inflammatory response, especially something that's an extended inflammatory response, like what I had. Because in terms of that, I had a giant ball of pus that essentially was accumulating inside my abdomen. My macrophages, my neutrophils were coming in to attack that. As they were breaking down those bacteria, they're releasing lipopolysaccharide. That lipopolysaccharide then essentially signals to an area of the brain known as the hypothalamus. And what it does, essentially, is it hits a reset on your temperature. Because the hypothalamus is going to be one of the areas of the brain that's going to be critical in maintaining your body temperature. Because for the most part, your body temperature fluctuates at most either a degree below or a degree above normal within a day. All right, typically you tend to go a little higher towards the evening, you're a little lower in the mornings. But in terms of that, our normal temperature (98.6 degrees), that's Fahrenheit, 37 degrees Celsius, okay? And in terms of generating fever, typically where that level is set with a fever, you're looking at about 100.5 degrees Fahrenheit, 38 degrees Celsius, okay? So when I talk about the degree of variation, I'm not actually using the metrics here. I'm not using Celsius. I'm talking about Fahrenheit. So normal variation, 97.6, you could go 99.6. That still wouldn't be considered a fever, okay? To reach fever, you've got to be over 100.5 degrees Fahrenheit. I give you the Celsius because, believe it or not, once you get into a healthcare setting, you're going to need to know the Celsius, okay? So try and make those associations now, all right? So in terms of fever, the reason you want to combat fever usually is because fever can become fatal, all right? Typically, the numbers we're talking about there are going to be about 111 degrees Fahrenheit, although it can occur prior to that number. Or we're talking about 44 degrees Celsius, all right? So you definitely want to avoid that range, all right? But in terms of fever, we always tend to think of fever as being a bad thing, and it can be because it can result in fatality if it goes too high. But a low-grade fever can actually be beneficial to clearing an infection, okay? It's part of the normal innate immune response, all right? That fever, essentially what it does is it increases transferrins that are circulating in the body, and essentially kind of pulls iron out of your system, because bacteria need that iron in order to replicate. So in order to make more bacteria, they need iron, all right? So in terms of that, you get an increase in transferrins, which decreases the availability of things like iron. You can also decrease the availability of other nutrients like zinc and copper, which are needed by the bacteria. That helps inhibit bacterial cell growth, okay? And in terms of that, the big thing that you're going with there when you've got a fever, all right? I've run out of space almost. Is that you're going to start denaturing proteins, okay? Because in terms of those bacteria, their window is a little smaller than what ours is. So if we go above our window of normal a little bit, we're actually starting to denature the proteins associated with the bacteria, all right? The bad part of fever is if you continue to build the fever, if you continue to reset the signal to the hypothalamus so that instead of 37 being normal, it raises it to 38 or 39, all right? What ends up happening is you'll start denaturing your own proteins, all right? That's why doctors will tell you if you have a fever that is more than 104 or especially 105 degrees Fahrenheit, that's when you need to seek medical attention, okay? With little kids, you kind of want to go a little bit sooner than that because little kids and infants aren't as good at controlling overall body temperature. So with small children, that fever can get out of hand a lot more quickly, all right? And in terms of that, if you continue to increase in temperature, proteins start denaturing, that's when bad things happen to your body, okay? That's the bad part of fever, all right? Good part, low-grade fever can actually help fight disease. So the iron and transferrins is one. You also get the production of some proteins that can target bacteria specifically, all right? You can get an increase in your interferon level. Interferons help fight proteins, and I've got another video after this one that we're going to talk more specifically about interferons. You're also raising levels of certain cytokines, which can help raise your metabolism. As you speed your metabolism, you'll start to fight those off, all right? So in terms of fever, fever does go kind of hand in hand with the inflammatory response, all right? But in terms of that, low-grade fever can actually be beneficial to eliminating whatever pathogen happens to be inside of you, all right? Again, low-grade fever, we're not talking high-level fever. We're not talking above 102 here, all right, in terms of number. But fever can actually be beneficial, And this is also part of your innate immune response to fight off infection. All right. If you have any questions, please let me know.